Think about the ground beneath your feet. We assume the Earth carries billions of years of lived history. But if you analyze our environment like a software engineer, the physical evidence points to a different reality. Our world is a simulation that ran its initial boot sequence only a few centuries ago. In digital world building, the architecture of the Florence Cathedral represents the moment the engine reached its current rendering capacity, establishing the now of the simulation. Everything predating this period, from the Middle Ages back to the Bronze Age, functions as a pre-compiled lore file. The system loaded this backstory into the matrix as a static dataset to provide human avatars with a convincing, albeit unlived, history. If our ancient history is a manufactured background asset, we have to change our approach. We need to stop digging in the sand for archaeological artifacts and start auditing the physical world for software errors. The claim that the ancient world is a preloaded save file sounds extreme, but look at what happens when a systems analyst reviews the raw environmental data of our earliest monuments. This system diagnostic reframes the Giza Plateau. It identifies the Great Pyramids as a technical exposure, a visible structural error where the simulation's internal logic breaks through to the surface. To maintain a stable frame rate, any digital world must conserve memory. Dropping a massive static placeholder into the environment allows the engine to inject a background story without calculating real-time physics. Notice how the system pathway routes directly to bypassing compute overhead. By leaving these massive, low-resolution placeholders in the environment, the simulation exposed its own hardware limits. The pyramids are a processing shortcut. To understand why the simulation relies on this specific shortcut, we have to run a computational audit. We need to weigh the processing cost of different physical assets against each other. Consider what it takes to render a fluid, non-repeating organic entity, like a massive oak tree. The system has to calculate real-time physics for thousands of leaves and track deep cellular depth. The processing cost is significant. This diagnostic matrix compares an active organic entity with an environmental megalith. Notice the internal details. The pyramid is a hollow, simple Boolean mesh, requiring purely surface-level rendering. Looking at the synthesis at the bottom, the computational cost drops from critical to negligible. The engine operates by a strict rule. It prefers primitive, repetitive block structures to anchor its physical space. This saves critical GPU power for active organic life. This top-down schematic illustrates exactly how the geography is optimized. In computer graphics, a draw call is a system request to render a specific object. The Giza Plateau is mapped out as a collection of unbroken geometric shapes to minimize those system draw calls. The design also utilizes asset duplication. Look at the breakdown here. Instead of rendering millions of unique stones, the system mathematically multiplies a single base block texture across the entire mesh. But an empty, mathematically perfect block mesh raises suspicion. To legitimize these background assets and sell the illusion of history, the simulation assigns character tags to the geometry. That brings us to the supposed architects. The legendary kings, Khufu, Khafre, and Menkaure, are non-playable characters. They are dummy variables pinned to these primitive shapes to anchor the lore file in human terms. The Giza Plateau lacks the material variation and irregular errors of human construction. It is a highly optimized background loop populated by programmed avatars. How exactly does this rendering trick work? How does an engine use basic shapes to convince millions of human avatars they are part of a vast, ancient timeline? This flowchart maps the illusion. Step 1 injects primitive geometric shapes as an anchor. Step 2 applies a static texture map for a weathered surface. Finally, the cognitive hack. Human observers automatically extrapolate these simple inputs into millennia of non-existent history. The concept of deep time is an optical illusion engineered specifically to bypass the hardware constraints of the simulation. Discard the romanticized historical view of human antiquity. Look at the data for what it describes. Look at this split-screen visualization of the Great Pyramid. Strip away the textured stone, and you uncover the resource-saving digital architecture humming underneath. The miracles of human antiquity are the visible seams of a simulated existence. This diagram captures the ultimate reality. Trapped within the geometric grid dome, these megaliths reveal the foundational source code of our existence. System diagnostic complete. What humanity calls history is a successfully executed background asset load.